But right now we're just going to focus on this part right here and take a look at the mail bit. The mail bit, and retrieve the mail, and then we'll have another video to talk about the rest of this stuff. Okay, so let's take a look at the code. So here is gmain.py. That is the basic code, and it's hopefully this stuff is starting to look familiar. The thing that's weird here is we got to do some date-time parsing. And there is code that's out there, but you may have to install it. And I had to write my code in a way that didn't assume that you could install the date-time parser. And so it has it, even if that's not there, it uses my own date-time parser, and that's what this code is. Don't worry too much about that. And of course, we have to deal with the lack of certificates inside of Python. And so we start things out. And this is really a simple table. We've got a messages table that's got a primary key, the email itself, when it was sent, what the subject, and the headers and the body. Okay? And so what we're going to do is, because we have to pick up where we left off, we're going to select the largest primary key from the messages table and retrieve that. And then we're going to go to the one after that, okay? And so we know what the ID is, and we're going to pick up where we left off. And so we have a starting point, and it starts either 0 or 1, and we're going to ask how many messages to retrieve. We've got some counters, and so we're going to say, okay, see if select ID for messages where ID equals whatever that starting is. That's the highest number we've seen so far. And if row is not none, that means we've already retrieved this particular email message. Otherwise, we're going to keep on going, and we're in good shape. And this is one that we want to retrieve, and we're subtracting that so we don't. And so this is the base URL. This is the URL of our API, the one that I copy. I have a nice copy of all this data on a server that's accessible worldwide and won't crash. So the format of this is, you can say I would like the email address for from 1 to 2, or from 100, from 102, 101, message 101 to 102, and we can just kind of walk through these things. So that's the message ID. And so if we're going to make the URL, we're going to take the base URL, add the starting address, and then add +1. So we got the slash at the end of the starting address, and so that's how we form those. And we're going to retrieve that, and we're going to decode it. We've seen this in some other ones. We're going to check to see if we got legit data. If not, if I got a 404 not found or something else, we're going to quit. If someone hits Control-C, or Control-Z, we'll get the program interrupt, and we'll stop. If there's some other problem, right, we're going to complain and keep going. And if we have 5 failures in a row, we're going to quit. But it will just keep on going, because these things do have glitchy bits here. And so at this point, if we've made it this far, we've retrieved the URL, and we've got the number of characters we've retrieved. And if we get bad data, if it doesn't start with from, because this is a mail message, right? And they all start with from space. If it's right, it starts with from space. Then what we're going to tolerate up to 5 failures there for bad data, because it could be bad. And then we're going to find a blank line, because that's the new line at the end of one line, and then a blank line. And then we're going to take and break this into the headers, the mail headers, which is, that mail headers is this stuff right here, up to, but not including the blank line, and then the body is everything after that, okay? And so we'll just break that into pieces, otherwise we'll complain and tolerate up to 5 characters. And then we're going to use a regular expression, kind of from the regular expressions chapter, to pull out an email address from the from : line somewhere in these headers, from : right there. It's going to go find a less than, and then pull, come on, pull this stuff out up to it. So you got the less than, you got the parenthesis, you got one or more non-blank characters followed by an @ followed by one or more non-blank characters, and we'll get back a list of those. We should only get one. If we find one, we're going to grab the email, we're going to strip the lowercase, and if we got some little nasty less than sign in there, we'll tolerate that as well. So this is kind of cleanup, and you get used to this where you're like, oh, how come all those email addresses have this other stuff in them? And then we also look for it if there are no less than signs, and we do this way. And that's different. Some mail messages have it this way, and others, again, you write this code after you watch it for a while. You're like, oh, it's crapped out and giving me bad stuff. And I make them all lowercase so they match better and get rid of bad characters. Well, now I got an email address. Then what I do is I look for the date of this. So I'm going to graph these by date. So I look for this line and use a regular expression to pull that out, right? So I'm looking for a date followed by a blank, followed by any number of characters, followed by a comma. So I'm not interested in this Wednesday bit, so I'm skipping that bit right there and going and grabbing everything after that comma space. And so it's really here to the end of the line. So that's the new line. And so it's going all the way. It's going to pull this bit right here. That's the text. And this is where we're going to like say, oh, that's kind of a funky looking date, and we want to standardize that date. So we're going to, let's see. Yeah, we're gonna chop it off at the 26th character. Apparently, I don't know what the 26th, why we care about the 26th character, but we chop that off at the 26th character, and then we're gonna parse it, and that's gonna give us back a nice clean date, sent at date. Otherwise, we're gonna complete. We're gonna quit, and if we can't parse it, then we're gonna tolerate 5 bad email addresses in a row. Then we're looking for the subject line using another regular expression. Subject line. Regular expression, that's pretty easy, up to but not including, right? There's a blank there, it's the subject. And we pull that out, we get the subject. Now at this point we've parsed it and we got good stuff, so we reset the fail counter because I kept saying if you fail 5 straight times you quit. And we're going to print it out, and then we're just going to insert that stuff. We've got the ID of the message, which we've got the email address that it came from, the time it was sent, the subject, and then basically the headers and the body, and we're just inserting it. And now we're going to say every 50th we're going to commit it, so that speeds things up, and every 100th we're going to wait a second. So that's, count is going up, 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 and every 50th you'll see it pause, and then it will, every 100th it'll pause for a second. Mostly that's to let me hit Control-C or to not overload any server. Okay, so that's the simple one. The problem is this data just gets ugly, and so you'll find yourself wanting to reset this and start it over. This one's going to work, of course, but these are hard to build, and that's why it's a good idea. Oops. Python 3 gmain.py. How many messages? Well, let's just do 1. Okay, so it went and grabbed, oh, do I have this already running? 51 through 52. Let me start over. ls-l star SQLite. Okay, rm content. I must have run it to test it. So let's run it again, python gmain.py, and ask for 1 message. Okay, so there we went and got message 1 from 1 to 2. We got 226 characters, and we printed out the email address, the time we got it after all that hacking, and the subject line, and that's what we got. So if we take a look at the database and we go into the Gmain, anytime you see the content SQLite journal, that means it needed to run a commit, and it hasn't run a commit, but I'll hit enter and that will do the commit, and you see that vanish. So now I can open it and I take a look at, how come there's no messages? Did that one not get stored in there for some reason? Just refresh. Well, let's run it again. Maybe it didn't commit. Maybe I got a bug in it. Let's make a change to the code. I'm going to see this connection.commit. See that? Connection.commit. I'm going to commit there. And the other thing I'm going to do is every time I stop to read, I'm going to commit right before I read it. So I think we should, I hope that doesn't blow up. We'll see. So the idea is if I want to stop, I want it committed. So let's do this. Let's do one message. And now I should hit, is it committed? Now that I've put the commits in, I think that it will look better. And I can't refresh. And so there it is because I committed it. And I don't have, I don't have the journal file, so that's good. So that's a good idea to put those commits there. So I'll just leave those commits in. When you download it, it'll have those commits in there. So again, I put a commit here and a commit at the very, very end to make sure. And then I missed that. But now we get one, right? And so let's just run it again, and you'll see how by selecting the max of the ID, it's going to select the max of this and then add 1 to it, so it doesn't do the next one. So if I run it again, I say give me 1 message, so it goes 2 to 3, and give me 2 messages, right? So I hit enter, and I can do refresh, and now you see we've got 4 messages. Okay, and so let's just fire this baby up until it get 100. Run, right? It just goes and goes, and it pauses once in a while to do a commit. And if I made a commit every time, it just paused there. Now it finished. So this will run, and we will get a bunch of data. The problem is if I just run this, it'll take about 5 hours, okay, to run this and get this all. And I've got a really fast connection, so I have got a file that you can download. Let's go find it. Let's see if I can, let's see how long it'll take me to download this. I've got a file that you can download and save. Now I'm going to use the command line curl, or wget is another command that we Linux and Mac people can use. I don't know, you might have to use your browser to do it. Let's see how long this is going to take. It's retrieving. Minute 30. Okay, well I'll just wait when this comes back. Okay, so now that's done. I was averaging 10 megabits a second. I downloaded about 600 megabytes, 10 megabits a second. That will probably be slower for you. But so now if I take a look, you're going to find that content.sqlite is 624 megabytes. Now what happens is I've pre-spidered this, and so now if you run gmain.py and ask for 5 more messages, it will pick up where I left that one off. So it's up to message 59,000. And I think that, oh, you saw an error. See, you saw a bug in that one. I don't know what's wrong with that one. So let's see if, so at this point we're going to have most of the data. It might find its way to the very end. Once you get this, it should be not too much more. I don't know, maybe it's like 63,000 or something. So what we'll do is we will let that run, and we will come back when that one's finished and run the next phase after it's got all of its data. Okay? So thanks for listening. The work that we're doing right now is we are in the process of building a spider and visualization tool for email data that came originally from this website Gmain, but I've got my own copy of it. And so what we've done before is we ran gmain.py, and I grabbed a URL. I have a URL that has all this data, and I downloaded that, and then I ran gmain again to catch up. So it took quite a bit of catching up. But by the time I get to, remember how I said it tries to fail 5 times? Well, it ran out of data at 60,421, and then it started failing, and then it quit. And so we pretty much have all of our data now. We have finished this process in Content SQLite. Okay, and if I take a look in the database browser, we can see we got 59,823 email messages. And so if I look at any of these things, you see the headers, you see the subject line, you see the email address, you see the body of it. So remember, I split the body in half and headers, and so I made this as raw as I possibly could, because as you saw, I had to spend so much time in the gmain just getting the data successfully retrieved, and so I don't like cleaning the data up too much. And so what we're going to look at next is the data cleaning process. Okay, and so this is gmodel.py is code we're going to take a look at now. So let's get rid of those guys and look at gmodel.py. I don't think I need URL lib in this code. Do I have any URL lib? No. So I don't need that. Sorry. Fix that. Okay. So it's going to read from the database. It's got to call. It's going to use regular expressions, and zlib is a way to do some compression. And so I'm going to do in this one. I'm going to compress some of the data to make it so that I have less data. Some of the text fields are going to be compressed. I wanted to keep these fields uncompressed inside of messages, so we have some just cleanup messages and cleans things up. And it turns out that the way email addresses in this particular mail corpus, they changed over time, and there's certain kinds of things. Sometimes the gmain.org is the email address when people want to hide their address. And I made all kinds of stuff, and I split it and checked to see if it ended with this, and I cleaned up things, this, that, and the other thing. And so I have all kinds of cleanup stuff going on in here. And I have this mapping and DNS mapping that I'll talk about in a bit, where organizations sometimes sent email with different addresses over time, and people sent email from different time. And we're going to do the parsing of the date, and that is the code for that. We're going to pull out the header information. This is sort of borrowed from the other code. We'll clean up the email addresses and the domain names. And we'll pull the date out, pull the subject out, pull out the message ID, various things. So here's the main body of the code. We're going to go from content.sqlite to index.sqlite. And what I'm going to do every time is I'm going to wipe out index.sqlite and drop the messages, senders, subjects, and replies. So this is a normalized database in that it has foreign keys. So there's a messages table here with an integer primary key, the GUID for it. The GUID stands for Global Unique ID, sent time, sender ID, and it's going to have a blob. These are blobs, binary large objects for the headers and the body, because I'm going to compress them in this database to make them. And then the senders each sender has a key, and then subjects, each subject line is going to have a key, and then replies are a connection from one message to another, and so this is like a many-to-many. Now, I also have this file called mapping.sqlite, and so we can take a look at that one, mapping.sqlite. And so what happened is this has two tables that I hand deal with, and so sometimes Indiana, this was a email address that mapped to that. So indiana.edu, that's a way to take an @ the email address, and then these were a bunch of people that had email addresses changing throughout the project, and I sort of kind of mapped them in a way. And so this is just sort of like I pull this in really quick, and I read all this stuff from the DNS mapping, and other than stripping and making this lowercase, etc., I just am going to make a dictionary. DNS mapping, which is the old name to the new name, and the email address mapping from the old name to the new name, and I'm using fixed sender. Fixed sender is because the email addresses, even within Gmain, were kind of funky. So don't worry so much about this. Okay, and so now what I'm going to do is I opened up a connection just to read all that stuff in, and now I'm going to actually open the main content. And I'm asking it to open this a little trickier. I opened that read only. That was so that I could potentially be running the spider and running this at the same time. I get a cursor. And so I'm going to read through, so in the content file, this is the big one, I'm going to read through and go through every one and write all of these things in. And I'm going to take all the email addresses and I'm going to put those in a list. So I loaded that. I've got the mappings loaded. And so now I'm going to go through every single message. I got all the senders, all the subjects, and all the global unique IDs. So I read in each message. So now I'm going through content one at a time. I parse the headers. I check to see if the sender's name, email address after it's been cleaned up is in my mapping.get sender, and the default is I get back sender. That's what that's saying. Look up sender. If it's in there, give me the entry of that key. Otherwise, give me sender back. We're going to print every 250 things we do. We'll complain if this is true. We're going to go get the mapping between the senders, which is a way to look up the primary key. I could have done this with a database thing, but I wanted it to be fast. So that's part of the reason I read all these things in, so I could have those mappings to be really fast. You'll see this takes a little while, even though it, even though it's I got all this stuff cached. And so then, if I don't have a sender ID, meaning that I haven't seen it yet, then I'm going to do an insert or ignore into senders, and then I'm going to do a select, and then you've seen this where I grab the row back and I'm really just trying to look at the recently assigned ID, and then I'm going to not only set the sender ID for this iteration of the loop, but I'm also going to store it in the dictionary, and so that builds this dictionary up. And you'll see the same thing is true for subject ID. I'm going to insert it into the subjects table and get a primary key if I don't know what it is. And then I'm going to put it into, not only am I going to put it into the database, but I'm also going to put it into my dictionary. And the same thing, I guess I didn't do it for the GUID. Okay. So now what I have is the sender ID and the subject ID, which are foreign keys, into the sender table and the subject table. And I'm going to insert the message with the sender ID, subject ID, the sent at, headers, and body. And the values here are the GUID, sender ID, subject ID, sent at. Now this here is zlib compress. So what I'm taking is the message, the header, and the body, and this little bit ends up with a compressed version of this stuff, and you'll see it in a second. And this keeps the size of these text things down at the cost of the computation of, at the cost of the computation to compress and decompress when we want to read it, okay? And then I pull the GUIDs out, the ID, which is the GUID, and I pull out the primary key for this thing based on the GUID, and I update this dictionary, okay? So let me run that code. It is doing a lot of cleanup, and I'll tell you, it took me a long time to make this work. So this code that I'm running now, oh, don't forget to take a Python 3, Chuck. So this is going to run every 250. So it did all this pre-caching, so that's how long it takes to do 250. Now there's 60,000 in here. And so this is really busy. The reason it's bouncing back and forth is that every time it makes this journal file, and then does a commit. So you can kind of see that it's busy making journal files and committing, and there's a lot of activity going on here. Just so happens that Adam shows me these files. Okay, so it finished. It took about 3 minutes to finish that, right? And so if we take a look at the size of the files, we will see that the index is much smaller. It's fully normalized. It's still 263 megabytes. It's all compressed. So let's take a look at that in the browser. So it's 200 megabytes, but it loads up a lot faster. There we go. So we have a senders table, right, which is just kind of a many-to-one table. We have a subjects to table, which is a many-to-one table. And we have messages, which has foreign keys. It takes a little bit to load that up. Okay, and so we see the foreign keys for sender and subject, and that saves us. All those foreign keys save us. And so we have, you can kind of see that I can't see the headers in the body because now they're compressed. That saves me a whole bunch of stuff, right? It saved me a whole bunch of stuff. You know, and so that's what's in that file. And that we've finished this process, okay? And we've finished modeling the data and making it really clean, and we'll pick back up, and the rest of the stuff we will do is actually visualizing pulling data out of index.SQLite. The idea is this can be restarted, this can be run over and over and over, even though it takes like 3 minutes to run this. That's way better than 5 hours to run this. So 3 minutes, 5 hours, and then you'll see, and we'll see now reading this is in seconds because we got it all nice and normalized in a quite pretty way. So I hope this has been useful. In the next one, we'll actually do the visualization. We are in the process of retrieving data from this Gmain server, one that I've made a copy of. And we have so far spidered it all, ended up with 600 megabytes of spidered information. We have ran a rather complex cleanup process that you probably don't need to fully understand. You can look at it for patterns, but in general, the cleanup process will be very sensitive to the data. And then we have this index.SQLite, which is 260 megabytes right now. And we're going to now do the fun, easy bits here, where we're going to run little queries that just pull data out. And so these are much simpler. So part of what I wrote when I was doing this is I wanted to do some simple, basic calculations on the data to make sure. I really was sort of looking for anomalies, right? What was working, what wasn't working. So I wrote a series of really simple things like this GBasic. The GBasic code, just give me some basic data, right? So I wrote things down and I counted things, and so do I need URL lib request in this one? I don't think so. Let's fix that bug. It's not there. No reason to put any of that stuff in there. So it reads that index.SQLite, which is our cleaned up data. It reads through and makes a dictionary. This pattern you're going to see a lot, where I'm going to make a dictionary of ID to senders, save myself repeatedly looking at things. I'm going to grab the subjects. I've cached them all. I could have done this all with SQL, but I just wanted to do things faster. And now I'm going to go through each of these messages and make a dictionary of them. I'm going to put a lot of stuff in memory, and then I'm going to do some counts. I'm going to see who is sent the most, right? The organizations. And so now I've got to go through the all the messages. I am not actually, so you'll notice that I'm not selecting the body or the headers here. I am just getting sender ID, subject ID. I probably could have done this with a join. It would have been cleaner. You can do that. You can make that change. Do that with a join so it's cleaner. So I'm going through all the messages except not the body, so this is going to be really quick. And I'm pulling out the sender's ID. I'm breaking the sender into pieces. See, my data's clean now. I cleaned it all up in the previous processes. And if I don't have two pieces, I continue and I get the domain name. So I have the person. I'm doing a basic dictionary histogram for the people and the domains. And then I'm going to sort them, right? With a sorted, and we're going to grab the key, we're going to sort it by the how many there are reverse, and then print out the top few of the organizations and the top few of the people. Okay, so we'll just run that code. Python gbasic.py. Let's dump out the top 10. So we loaded 59,000 messages, 29,000 subjects, and 1,800 senders, and figured out the top 10 people and the top 10 organizations. And you can write various things like that that just sort of scream through your data, and it's good to get sanity checking on your data. Okay, so that's gbasic. Now I want to do gword.py, because that's kind of fun. gword.py. I don't need urllib. Why do I keep putting urllib in all these things? So we'll get rid of that. So this is really simple because I'm just going to go for the words in the subject line. And so I go through index.sqlite, I read in all of the subjects, and I make a dictionary of those, and then I go and find all the subjects. And then I'm doing this code right here. I'm pulling out the subject based on the message, and I'm doing this so that when the subjects are used more than once, I count the words more than once. This stir make trans, I talked about that in an earlier chapter. This basically throws away a punctuation in numbers, so that when I make my words, I don't end up with words that are like dashes. It compresses them down. Then I strip it, I convert everything to lowercase. This is basically just to keep too many words from showing up. Then I do a split, and then I got a counts, a dictionary. So this is a no punctuation, no numbers dictionary count. And then I just take and do a dictionary, and then I sort them in reverse order. And then I figure out what the highest and lowest is by running through I could have probably done this with a max and a min if I felt like it. And so now I have the highest and the lowest. Yeah, I should have done a max and a min on that one. Why did I do that? But oh well. And now I've got to spread out the size, and so I'm going to produce this file gword.js, which is needed by the visualization because it's going to use d3.js, a word visualizer, and gword.js. I have to tell it how big the text is, and so I'm doing some text normalization. Took me a little experimentation. So if I run this now, and I say Python gword.js, and I say Python 3 gword.js, which is a lot better. Oh, not Python. Okay, so now I can go look at the gword.js, wherever that is, gword.js, yep. And so this is basically, it normalized all the frequencies and made it font size. These are font sizes now, okay? And so this is just the data that's needed by this gword.jm, which uses this D3 visualization word cloud code. So this pulls in all my data, and then this is just some JavaScript that draws the picture on the page. Okay, and so the easy part now is to just open gword.htm in a browser. It just so happens on a Mac I can do this. And so that gives me a word cloud based on that data. It kind of randomizes it and shows different stuff, but it's using this. Oops, it's using this data to generate how big those things are, and then using a bit of randomness and simulated annealing to lay it out. That's not stuff that we actually have to worry about. Okay, so that's how we get to the point where we're seeing a word cloud from this. Now we're going to do another visualization, and this time we're going to do a line visualization, and we're going to create a thing called gline.js and produce with another HTML file. We're going to use D3 and produce that output. So let's say goodbye here, goodbye, 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 goodbye. So gline.py, get rid of that file. So again, I'm going to preload all of the senders in this case. And again, I could have done this with a join, probably should have done this with a join. I'm going to preload all the messages, the sender ID, subject ID, etc. I'll load those up. And now I'm going to read through. I'm going to have the sending organizations and the senders. And I'm going to split the senders, and I'm going to have the sending organizations. And then I'm going to do a simple dictionary as I accumulate the sending organizations by splitting the person's name into @signs, and then based on the organization I accumulate it, and then I sort them, and I pull out the top 10 organizations, print those out, and now I'm going to break this down into months. And I'll show you what this looks like in a second. Let's go to the gline.js. So the month looks like this. Okay, so the month looks like that. So that's the first 7 characters of the date. So if we look at the date looks like that, and the month is the first 7 characters. And this is the data that I've got to give it. We'll clean that up in a second. That data will look better in a moment. Go back to gline.py, and so this is we're doing the key is a tuple, which is the month, and which organization that did it, and it's only in the top 10 organizations. And then we're going to do we're going to basically do a dictionary where the key is a tuple. And then we're going to sort it. Sort by key in this case, not by value. That's in the months is going to sort that. And then we're going to write all this data out into gline.js. So let's go ahead and run this. And again, this is just the data that has to be written in a way that the JavaScript can understand it. Python, gline, Python 3, gline.py. Okay, so top 10 organizations. So now let's take a look at that JavaScript. So this is what it looks like. So it just so happens that you got to tell it these are the data points. These are the lines. So this is the year, the line for University of Michigan, gmail.com, swinsburg.com. So this first column is that line points, and the next line points. So all this code was to get the data in such a way that I could produce this JavaScript file, because if I look at gline.htm, I need that data in that particular format, and I've got all this stuff. I make a line chart and I draw it with this data. That data, I had to go read all the documentation on how to figure this stuff out, right? And that's the data that I'm going to use, and I had to figure this out, and I had to transform it and make it pretty. It took me quite a while to get this to work, and this is not a JavaScript class nor a how to visualize in D3, but basically we pulled all that stuff in, and here's the gline that came from the JavaScript, and then it makes an array data table, and then that data table is what gline draws. So with no further ado, let's open gline.htm to show that data. So there you go. That's the Sakai developer participation from 2015 through 2005 through 2015, based on which organizations did the most commits in Sakai. And so I know that I haven't done this all this code full justice. There's a lot of code here. The fun is just to kind of run it and see it, and then when the time comes to come back and see the techniques that are used when you're trying to build your own visualization pipeline. So I hope that you found this useful. This is a lot of code, hard to explain in 15-20 minutes, but I hope you take some time and look it over, and I hope you found all these videos. This is kind of the last walkthrough video for chapter 16 of the book, and so I hope that I will see you on the net.